Hello again, this is UML Operator. Okay, in this session we're going to be talking about Platform Independent Modeling, or PIM, as we move into Domain-Specific Language, or DSL, pertaining to Model-Driven Development, Model-Driven Design, and what I like to refer to as Model-Driven Delivery. Now I'm just going to touch on this subject as we're moving through in this session. I'll be covering it more in detail in a series, another video where we actually go through the entire project. We use the tooling at the moderate level, I want to say. I'm not going to be going down in the detailed level because it depends on the complexity of the project, size of the team, and other things. But I'll cover that in another video. All right, so in this session, I typically start out with requirements. And those requirements provide nouns and verbs that help us set up some objects, some class elements that we're going to be dealing with. So I'm going to go ahead and double click this and open this up. So in this particular case, as we've gone through the requirements, I'm just sitting there listening to the stakeholders, and I'm coming up with some ideas based on my experience and other conventions, right? So we essentially need a content management system or article management system or document management system. And I associate these to content management platforms and architecture. So first thing that I focus on is the actual content store model class element that we're going to be building our requirements to. Then, because we deal with multiple content providers, I want to create a separate entity or entities, if you will, around content store. And content stores typically have the way of putting content in an area for a particular stakeholder, user, customer. And in the e-commerce world, we refer to that as a cart. So I'm going to bring in a cart element, which we're going to build around the ideas. And then there requires socialization, collaboration, feedback. So I'm working off of a social content pattern, and I'm simply using the term comment. I could have used feedback and so on. Because we're dealing with multiple or separate or disparate content providers, I want to know the location they're coming from. And then in the content itself, we want to start classifying the content so that we can search it. We can run analytics on it. We can keep it pertinent or personalized to specific users, whether those are customers or those are agents, technicians in the field, or any other stakeholders. So I'm going to break it up into content type, which is my primary classification reference, subject area, and then drill down into the specific subject itself. So I've just started with, a half dozen, climbing up to a dozen elements to focus on as we're building or approaching solution and design. So typically we start with some small boxes to focus on or talk about. They just set the framework. We can come in at any time, of course, and change and update our references, all right, as we're moving forward. But eventually we move to starting to draw relevance from either requirements we've collected or the ability to develop requirements at the element level. So Sparx gives you the ability to actually develop requirements at an object or element level. Any element is treated the same in Sparx. So we might come in and we have a first requirement, content management. We need CRUDL capabilities. CRUDL essentially stands for create, read, update, delete, and list. Then, of course, we're going to have access constraints on various content elements. And then we're going to want the ability to separate our content storage areas because we're dealing with multiple content vendors or providers as we progress. Thanks for spell check there in Sparx. And we'll start building our requirements. This is a very productive way to elicit requirements during requirements development. It's when you're able to associate nouns and verbs with specific pictures, graphics. It's more meaningful, and I want to use the term powerful again because I've been doing this a lot of years and it is powerful between your technical or your non-technical stakeholders. So they may not know what a content store model is. And they may ask the question, why didn't you put a space between these words? And as they're getting into it, they do start to see the nouns and verbs. Oh, yes, I agree. And then you start drawing a ubiquitous language between your technical developers, architects, technical stakeholders, and your non-technical stakeholders. And I don't mean to be rude and say that every client is non-technical, but in a lot of cases, your clients, they need to be able to keep up with the speed that you're delivering their wants and needs. So in this case, this is extremely useful. So we can come in and we can internalize requirements at the specific level. We can start socializing and collaborating with technical and non-technical stakeholders as we're building out these elements and for our solutioning. So a solution approach is who is going to do the what, where the what are the requirements. All right, so let's drill down into this first element right here. I'm going to double click on it. We're going to bring it up. I want you to know that I haven't chosen a technology yet. I haven't chosen a language yet for this element as we build it out. And so at this particular case, it is platform independent, PIM, platform independent model. As we start to look at different technologies and languages, then we start moving to domain specific language or DSL. So right from this dialog box, you can go to details. And when you're working with the client, when you're looking at the nouns and verbs and the requirements, here you can start bringing together an idea of your attributes and your operations. So if I go back to general and we go here, let's start with operations. I always start with functions first. You can start with attributes first. It's up to you as you're moving through design. We're not going to worry about anything above at this point. So I'm going to select operations. So as soon as I do that, it goes into this features window. Mine's in the lower right. Yours may be in a specific area of your modeling tool. And because one of the first requirements is around the notion of create, read, update, and delete, we're going to just bring in some simple functions. One is we want the ability to create, so insert. We want the ability to update, so here's another operation. We want the ability to remove or delete or mark delete. And then, of course, we want the ability to list, so we want to be able to go out and grab content based on specific criteria. So I'm just starting with these, and there's certainly a lot more. So let's just pretend for a moment we have enough requirements to get started in this iteration in this project. So what I'm going to do is I'm going to double click in here. I'm going to go to elements and I'm going to turn off requirements. I'm going to hit OK. Now requirements are turned off, right? And I can size these if I want back to anything that I want, right? I'm going to double click again in this and let's start exposing our operations. So I can go in here and say, hey, I want to show operations only. Eventually you can come in and put in attributes. Well, let's just start with operations. I'm going to hit OK. So as we've gone through, you can see we've started to build some operations based on requirements for our particular design elements. And again, this is platform independent. You know, it's going to support high level design, but certainly not going to be relevant at this point to design and code development. All right, let me add the last one. Get content by rating. I've typed that in here. The return type is going to come out of the content store. Select, grab the content store element, which is right here. Hit OK. And we're going to want to list these. So we'll come back and apply that depending on the technology, the approach we're going to use. We could use link. There's lots of different libraries and capabilities out there to do what we need to do. And we haven't outlined our parameters. but we don't quite need those right now. Like for instance, this one is going to be an integer, and I am not going to get into that right now, right? We'll do that a little bit later on. Maybe in this session, not sure. All right, I'm going to separate this, go to layout, just evenly space them down below. Hit save. And then I think we're ready to generate some code. Just some high level, we call it stubbing out code that we can pass on to application architects and developers, to help us out. If they've got something visual, it helps them. A lot of developers don't need UML, but they certainly enjoy coming to the team environment, looking at what we've generated based off of requirements and other things. So we're going to generate some code now. So we're going to select just this element right now, not all the elements. We're going to go to Develop tab, and we're going to go to Source Code, and we're going to select Generate, and let's generate a single element. So a little bit different than all. Let me close this for a second and show you. If you hit Generate, selected elements, it will go through, take you to your repo where you're storing your code design or code itself, but we're not doing code right now, and save it there. But we're going to go to generate, we're going to single element, because I want to show off this dialog box here. All right, in this dialog box, you're allowed to choose the technology that you want to generate the code in. Right? Now remember, I'm going to close this for a second. Remember, we haven't made up our mind yet, right? So this is really none. I go to this one just to double check. There's no technology, no language chosen, right? Sometimes when you're doing the operations, because you want specific selections by default in your attributes and your operations, it helps to have the technology chosen. But in this case, we're going to go with none. So select it again, go to generate, single element. This time it sees there's no target language. We're going to choose C#, all right? And from choosing that, it knows to grab CS as our extension. It takes the object name. That's why I use camel. I don't have spaces in between the words, content store model. And it forms our code file automatically, all right? And so we're going to go ahead and hit save. Now I didn't generate it yet. It's just saving where it's going, right? And then you can do other things such as adding your import and headers. This would be your includes, your libraries, and so on. So you can add those. But we're not going to do that. We're simply going to hit generate, and it generated that code that fast, all right? So now when we select the element, we can hit function key 12, F12, and it actually brings up, it stubs out the code that we're going to use based off the technology that we chose, which was C#, right? CS, C#. Okay, so you're able to stub out code, ideas, pass it back and forth as you're going forward. Now, I don't normally do it from my platform independent model. I normally bring these elements into a domain-specific language. So I start with 4, C#, Java, JavaScript, Python, right? These are the primary programming languages that I use. I also develop in C++, and there's other languages that I have to choose from. But as a solution architect in this project, just going forward, starting with some simple requirements, starting to pivot over to the more technical stakeholders, we're going to start having a conversation to meet performance requirements, scalability, and other things. Which language should we use? Eventually, we're going to microservices, but our prototype is going to be a monolith, all right? Monolithic architecture style. But we ultimately, in the final development, we want to get to a service-oriented architecture style, a microservice architecture style. And that may include different languages to do different things, achieve different objectives in the clients. So this gives us the ability to do this. So I create a package called C#. It's a blank diagram. I come over to my PIM model. I hit Control A to get everything, Control C to copy. I go over here and I hit Control, Shift, and V to paste as new. Right? I want to strip GUIDs. I want completely different elements. All right, so in this namespace right here, this package for C#, we have the same elements that were here. Now we have them under a domain-specific language. We're targeting C# in this validation exercise. So because I changed it to C#, it changed it here. It also remembers if I go to properties where the code file is, file name, where the code file we just generated was. So this is where you can find that. So I'm going to hit Control S to save. I'm going to go back to my platform. And in this model, I do not want it to be C#. I want it to go back to none. So none. And I want to Control A to select all, delete, so I don't have anything. All right. So now if I hit S12 here, it's not going into any code. But if I come over here and I hit function key 12, F12, it will go to the code that we just stubbed out with a date and time, who the author was. It automatically, because the way that Sparx is configured, brought in the proper libraries that I want to use for C#. And I'm going to choose link as a library that I want to use so that we can get more out of that framework for listing return data. Now let's look at Python. I started a package namespace for Python. I've got a blank diagram. We're going to Control A here. We're going to go over this blank diagram. We're going to get Control Shift and V because I want to strip the global unique IDs, GUIDs, and I want to paste those into this diagram for reuse. So you can see over in the Python folder, it's bringing in all of the elements with their own unique ID, right? So right now, this element doesn't have a language chosen. So what we're going to do in this case is here, we're going to choose Python, right, as our language, and we're going to stub this code out. So I'm going to hit OK. I'm going to come over here. I'm in development. I'm going to go to generate, single element. It saw the target language. Python is loaded in here. We're going to go to the exact same file source. Because we're using Python, it applied the extension py, and we're going to hit save. Now, I haven't generated yet, so nothing's been written there. And again, I can add in imports and headers. So I don't need to do that, right? And you can go to advanced, go to Python, and make any alterations that you want in your object specifications. But we're going to leave all the defaults. So we're going to hit generate, and it's done. So if I hit function key 12 here, now I've stubbed out code for Python, right? So here I could either, connect my IDE, my integrated development environment from the stubbed out code, and I can start building code around this that's in sync with Sparx. So you can work between I could actually develop my code right here in Sparx, but I use Visual Studio. I use my integrated development environment to stub out my code and to develop my code. All right, let's close this. Let's close this one. We're on our PIM model. Let's go to JavaScript. I develop in React and Node.js. So I believe that JavaScript may be the approach we need to go with. So I'm going to hit Control A to grab all of them. Again, I could do the model in JavaScript. I could do the content store in Python or C#. I can mix technologies and apply polyglot approaches, but we'll get into that in a later session. So let's Control C, come over here, Control Shift and V. We're going to paste as new all of these elements. There are no connectors, but always leave that checkbox on. And we're going to hit paste, and it's going to bring in those platform independent. In other words, no language has been chosen. And let's double click it, open up the dialog box, go to language, and we're going to choose JavaScript this time. We're going to hit OK. I could have done that over in properties, select an element, come into language and choose it there, but we're going to do it here, right? So the entire package was set to JavaScript, but I could do it at the element level from here as well. All right, select it. We've got our language, double check, yes. Let's generate. We're a single item. And matter of fact, I'm going to close. We're going to do it this way this time. Generate. It does everything for you. It goes right here. The extension's JS. We all know that for JavaScript developers. We're going to go to this repo for our high-level design, project approach. We're going to hit save, and it generated. If I hit function key 12 now I've got stubbed out code for JavaScript. So it's the exact same operations that we want to include now using JavaScript as the technology that we want to collaborate on and determine as we move through in design. So just to wrap up and prove the point, here we've got a content store model class. This class is done. The language chosen was C# for this. So we chose C# and we stubbed out our code. And then we got to a point where we were integrated with our IDE. I'm going to hit function key 12. And we're connected with the integrated development environment. To prove this point, I'm on this code file right here for CS. And if I go to my IDE, it's the exact same code. I can change the update date to today and hit save. And when I go back to the modeling tool, I do an update, it changed the date. So it was in sync. That warning that I got was that I'm out of sync. My current code view is out of sync with my IDE. The code had just changed, and it did an update out of that code repository and updated just this context as an element reference. So to prove how this is working, here is the actual solution for that article, bringing it in. So from the presentation layer to the code layer to the modeling tool, we're able to work between these integrated environments all the way from ideation, where requirements are being generated, through the development life cycles. And I'll show more of this as we get into a real project where we're implementing, but I greatly appreciate the time that you provided in watching this video, in your understanding of platform-independent model to a domain-specific language using model-driven design and model-driven development. Thanks very much for watching. Happy modeling.